Okay, how's everybody doing? How was your day off?
It all was good. Very good.
Excellent. Well, today math is on again. It's a joke because my name is Chase Matheson. Yes.
I thought you were just saying it to say it.
No, math is on, but also Chase Math is on. Yes. All right, so today we're going to be talking about the chain rule for people at home. My dog is here, so if you hear any barking, she'll calm down in a second, but she should be fine. Okay, so all right, so we're going to talk about the chain rule today. First, some announcements. We have an exam next week. I'm going to put up a review by the end of the day for everything that should be on the exam. I wrote it yesterday, so I think it should. It's pretty reasonable, I think. So I'm going to put up a review, like I said, by the end of the day. Homework is due Monday. Next week, there's not going to be any homework because there's going to be an exam. Okay, so. But make sure you get the homework for Monday done because the stuff on there will be covered on the exam. Okay, and then I've uploaded a few. I uploaded homework 1 solutions and I returned some feedback on homework 2. Make sure you look at that because just because you get 10 out of 10 on the homeworks, again, I grade for completeness. So if you get a 10 out of 10 out of 10 on the homework, that doesn't mean by any stretch that you're ready for the exam. Okay, so make sure you look back, know how to do all the problems, so that you can do well on the exams. Because the exams are where your grade will be made. You know. Okay, so those are the announcements. Any questions on any of these announcements? We got it. Maybe a Zoom question? Yeah.
How will like next week look during like that review? Is it like a review or learn some stuff?
Excellent question. I think I'm going to take a day to cover some new stuff and then 2 days to review. So Monday we'll learn some new stuff. Tuesday, Thursday will be review. Okay. Someone online asked about quizzes. Yeah, there will be quizzes in the semester, and I will. But those are also going to be, you have unlimited tries with those. So those will be all online. You'll be able to see what the right answers were. Okay. All right. So last time we talked about the chain rule at the very, very end of class. We talked mostly about the quotient rule and higher order derivatives, which are both important. The chain rule is, I would argue, the most important rule for you to learn for differentiating functions. Okay, so the chain rule says the following: if f, which we're calling f of u, I did this again. This should be a y. If y, which we're calling f of u, so y is a function of u, is differentiable, and u is a function of x, which we're calling g of x. If that if that function is differentiable, then f of g of x, the composition, is a differentiable function, and the derivative of y, this function of u, with respect to x, is just dy du times du dx. Okay. Written another way, and this is usually the way that I use it. Written another way is f prime, so the derivative of the outside function evaluated at the inside function times the derivative of the inside function. Okay. So when we're doing this rule, when we're using the chain rule, the first couple of times we'll identify like what is the outside function, what is the inside function, but most of the time we're just going to be able to look and cover up the inside function. It should be clear from looking at the function and differentiate and then multiply by the derivative of the inside function. Okay, so think outside, inside. Sometimes people call it the onion. rule because you're kind of peeling back layers. You peel back the first layer of the outside function by differentiating that. Then you peel back. And you could use multiple chain rules within one derivative. Okay. So a proof of the chain rule. For this proof, I'm going to use the alternate definition of the derivative. So I'm going to use the limit. If h is a differentiable function, then h prime of c is equal to the limit as x approaches c of f of, or h of x minus h of c divided by x minus c. Okay. Using this form of the derivative makes it a little easier to prove this. And like I mentioned last time, this proof isn't even technically correct. We have to be a little more careful than I'm about to be. But it's, if you make a few exceptions, this proof is fine. Okay. Oh, sorry, that's an x on the bottom. It's just rise over, oh, I said x and then I wrote x. It's just, yeah, rise over run and then take a limit, right? Okay, so the proof of the chain rule. Well, we want to show that we want to look at f of g of x prime. Okay, so we'll look at specifically at, we want to show that this is f prime of g of x times g prime of x, right? So I'm going to replace an x with a c here. It doesn't really matter. The whole idea is we want to look at the limit as x approaches c of f of g of x minus f of g of c divided by x minus c. So it's actually a little weird to write this out, but really the way we write this, I'm going to write it down because you guys, I think, are mature enough to use this kind of notation. Really, what you would write is, this is f of g, what we're writing here is the derivative of f of g of x, and then we're evaluating it at x equals c. Okay, so this means take the derivative of f of g of x and then plug in c. That's exactly what we're doing here. Okay. All right, and then this proof really just relies on the fact that this already almost looks like a derivative. I just need to put in, I just need to multiply by the thing that I want, right? And remember, we're trying to show that this is equal to f prime of g of c times g prime of c. So when I'm working out this derivative, then I want something that looks like the derivative of g at c to pop up. So in order to have that, I'm going to just put it in. This is the limit as x approaches c of f of g of x minus f of g of c. And notice if I put the g of x minus g of c over this x minus c, so in other words, if I multiply by g of x minus g of c and put that x minus c below that, well, that looks exactly like the derivative of g at c. But I can't just multiply by this thing here. I have to divide by it as well if I don't want to change anything. Okay, so all I did in this step was I multiplied by g of x minus g of c over g of x minus g of c, which doesn't change anything because that's multiplying by 1, right? And then I move things around to make it look like how I want it. Okay. Now, this is actually the point in the proof that's technically incorrect if I'm not careful. And who can tell me why? g of x minus g of c divided by g of x minus g of c, g of x minus g of c divided by g of x minus g of c. This is equal to 1 as long as what is true?
Denominator doesn't equal 0.
Perfect, exactly. As long as g of x minus g of c is not equal to 0. But if g of x is, say, a constant function, which we know that constant functions are differentiable, then g of x minus g of c is 0 everywhere, right? So this is where if I was being very, very technical, I would add in some notes about how if the denominator is 0, then we need to be more careful. But we're just going to assume that the denominator is not 0. Okay?
Are we gonna have to know how to do this?
No. You just need to know the rule. I'm just showing you a mostly proof. Okay. So going from there, this part here is just g prime of c when I take the limit, right? Does everybody see that? That's a definition of the derivative at for g at c. Okay, so this part here, well, that looks like the derivative of f, but with instead of f of x minus f of c over x minus c, I have f of g of x minus f of g of c over g of x minus g of c. And so this part, though, that looks exactly like f prime just at g of c. Okay, so this is equal to, this first part here, when I take the limit, is f prime, instead of just at c, it's at g of c. Okay, and then this part here, when you take the limit, is times g prime of c. Okay. Any questions on that? Now, like I said, this was not, you need to be more careful than I'm being here, but this gives you the rough idea of what's happening. This is the rough idea overall of the proof. Again, you just need to be more careful if you're really, really proving it technically. But it is a true theorem, and this gets across the main idea that it's f prime at the inside times g prime, okay, times the inside prime. So now we're just going to do 1,000 examples until the end of class. I feel like the only way to get good at the chain rule is to do it 1,000,000 times. So let's do that. All right, if f of x is differentiable everywhere, then what is the derivative with respect to x of f of x cubed? Excellent question. Someone asked, will we be asked to prove any rules on the exams? I would say no, but know what the definition of the derivative is. I might ask you, not might, I'm definitely going to ask you to prove certain functions are differentiable from the definition, but I'm not going to ask you to prove any rules from the definition of the derivative. Okay.
That means like
Yes, exactly. So you'll need to know how to prove, say, that f prime, if you're looking at, this has nothing to do with this problem right now. If f of x is, or I'll say g of x, is x squared minus 5x, then you'll need to show g prime of c equals, well, I'll say g prime of x. The limit as h approaches 0 of g of x plus h minus g of x divided by h. You'll need to be able to evaluate that limit and know that limit to prove the definition, or to prove the derivative of g. Okay. delete, delete, enhance. All right, back to this question. So yes, excellent question. No proofs of general rules on the exam. Okay. All right, so if f of x is a differentiable function everywhere, then what is the derivative with respect to x of f of x cubed? Okay. So my outside function here is just f of x, right? The outside is f of x. We don't know what f of x is, but I know that it's differentiable. So I can take the derivative. I can use the chain rule here. What's the inside function? So I'll write out equals, yes. Inside is just x cubed, okay? So the chain rule says, the chain rule says, well, cover up the inside. We're just covering up the inside. What's the derivative with respect to x of just f of x? Yeah, that's just f prime. So you cover up the inside and you say, well, the derivative of the outside function, well, that's just f prime. And then you plug in, then you uncover the inside, then you plug in the inside times x cubed, or f prime of x cubed, and then you multiply by the derivative of the inside function, right? So what's the derivative of the inside function? 3x squared, perfect. So f prime of x cubed times 3x squared, and we are done. No, I just prefer to do it that way so that I don't maybe think that it's going inside the function and I messed up something. Yeah, that's it. That's it for that one, yeah. Yeah, these kind of general problems are actually usually easier, but it's just harder to see that you're done, I think. Yeah. Any questions at home from anybody? Does everybody see that we're done here? That we took the derivative of f of x cubed. Okay. So, gave myself too much room there. All right, so we're going to use the chain rule to differentiate the following functions. 1, f of x is 1 plus x squared. 2, g of t is 4 minus t to the 100. And 3, h of s is equal to 1 over 1 minus s squared. Okay, so we want to differentiate these things. Okay, so let's look at number 1. Perfect circle. Oh, no. Square. Good enough. There we go. 1. All right. So for the chain rule, and almost all of your derivatives now are going to be chain rules, by the way. You're almost never going to have a derivative that's not a chain rule, at least at one point in the problem. So for number 1, what is my outside function? Yes, very good. My outside function is the square root of x. And what's the derivative of that function? Just the derivative of square root of x. Perfect. Minus 1/2, minus 1/2, right? Excellent. Okay, and then what is my inside function? One plus x squared. And with my inside function, I don't ever have to take the derivative. Okay, so what the chain rule says that f prime of x is equal to what? Yeah, so I take I look at the derivative of the outside. So 1/2 times not just x to the minus 1/2, but time at the inside, right? So 1/2 times 1 plus x squared. So there's f prime of g of x, or outside prime at the inside. Okay, and then lastly, you need to multiply by what? Yeah, sorry, I misspoke. You do need the derivative of the inside. So here you need, I meant you don't plug, yeah, I misspoke. a lot of people think that f of g of x prime, you just do f prime of g prime of x. That's never what you do. It's f prime of g of x times g prime of x, okay? So sorry for that misspeak, I was just being unclear. The derivative of the inside is 2x, right? So what do I multiply down here by? Yes, just 2x. You just multiply. So outside prime at the inside, and then times the derivative of the inside. So times 2x. Okay. So cancel my 2's, and then this is just equal to, writing it maybe in a slightly nicer form, x over the square root of 1 plus x squared. Did I lose anybody in that step there? Questions on that? Okay.
What happens to x from the 2x? Because the 1 plus x squared still remains the square root, but
Yeah, the x from the 2x is right here. Yeah, this x is right here. No, you're fine. No, I'm glad if people have questions, I'm glad we're asking. And then this part, 1 plus x squared to the minus 1/2, well, that just turned into this. Yeah, of course. Yes. No, not at all. Not at all. You only ever have to put your form. The key step, if you have this written down anywhere, you're right. You are correct. And if you're running short on time, you should move on to another problem. Okay. Simplifying most of the time, I don't care a whole lot about. And also, particularly on exams, I will phrase the question instead of just saying, most of the time, instead of just saying, find the derivative, I'll say, find the derivative at x equals 1, okay? And that way, as long as you did this right, whether you simplified to this or not, you and I will still get the same number. It's the same answer, just in a different form. But when you plug in a number, we should still get the same thing, okay? Yeah, excellent question. But I don't really care if you simplify the function beforehand in that context. Okay. Got a question online, it looks like. Can we explain how did the outside function is? Yeah, so the outside function is always the last thing you do to things. So if we think of PEMDAS, if you think order of operations, the outside function is going to be, well, the inside function, if I have an x, what's the first thing I do? The first thing I do to x when I'm calculating this, when I'm calculating f of x, if I gave you an x, what would you do? To calculate the square root of 1 plus x squared. Would you take the square root first? Yeah, you do what's under the square root first, right? So the first thing you would do is you would square x and you would add 1, right? And then only after that would I take the square root. So that's how we know that the square root function is the outside function, because that's the last thing I do when I'm actually calculating this. Okay. So is that helpful? I hope so. So for g of t here, to find if I just gave you a t, again, what's the first thing you would do? Would you raise it to the 100 first? No, the first thing you would do is what? Yeah, the first thing you would do is you would do 4 minus t, right? So that's my inside function. And then only after that would I say, then I would take this, I would raise it to what? Yeah, I would take that and I would raise it to the 100. So the outside function is t to the 100. Okay, so let me move over a page. So for 2, we've got g of x, or g of t rather, is 4 minus t to the 100. So like we said, the outside function is t to the 100. The inside function is 4 minus t. Okay, and so what's the t here, the derivative of the outside? 100 times t to the 99, perfect. And then what's d dt here? Just -1, perfect, perfect. And this is where this is technically this is a derivative we could have done before without the chain rule, but it would have been annoying, right? You have to expand that 4 minus t to the 100 to do it, which I'm certain you all could, but that's 100 terms of writing out stuff that no thanks, I don't want to do that. So g prime of t then. What is g prime of t? You guys tell me. Perfect. And then anything else? Times -1, yeah. So when you take the derivative, the outside function itself never really makes an appearance again. But you're going to take the derivative of the outside at the inside and then times the derivative of the inside. Okay. That's exactly what we have here. The derivative of the outside is 100 times t to the 99. When I plug the inside into that, that just gives me the 100 times parentheses 4 minus t to 99, and then multiply by -1. So are there any questions about that? This derivative that now would have taken us probably 10 hours to do before, now only takes us a couple of seconds. Okay. And then number 3. Number 3, we definitely could have done not even with much difficulty before, but it does illustrate a point that I want to show you. Okay, so this equation here, this function doesn't really look like a chain rule problem right now as it stands, but someone who's taken the class before probably knows what I'm about to say. So first, how would we take the derivative here without using the chain rule? Yeah, this is a classic quotient rule problem. 1 divided by 1 minus s squared. I had to say divided by, so when I take the derivative, I should use the quotient rule. And if you do that on an exam, that's perfectly fine. It's probably the same amount of time it's going to take to do the chain rule. Okay. If I rewrite this as 1 minus s squared all to the -1, then all of a sudden taking this derivative becomes a chain rule problem. Okay. If you prefer the quotient rule for things like this, that's perfectly fine. I do not care. But let's see how this goes with the chain rule, and we can compare answers with the quotient rule if we want. Okay, so then with h of x, what is the outside, bless you, what is the outside function and what is the inside function? So what's the first thing? If I give you an s, what is the first thing you would do? Yeah, the first thing you would do to calculate this is you would do 1 minus s squared. And then what's the last thing you would do? Yeah, I would take whatever I have, and I would raise it to the -1 power, right? Okay, so then the derivative of the outside is what? -1s to the -2, perfect. The derivative of the inside is what? Perfect. That one's power rule a couple of times. And really the top one's the power rule too, right? Okay, so the derivative of h of, this should be an s here, I apologize for that. The derivative of h of s with respect to s then is, well, I need the derivative of the outside evaluated at the inside, right? So negative something to the minus 2, and the something is just the inside, 1 minus s squared. And then I multiply by the derivative of the inside. So then I multiply by the derivative of the inside, negative 2s minus 1. Negative 2s minus 1. Okay. And if we do a little bit of simplification, this negative is going to make both of these a plus, right? And so I'm going to get 2s plus 1 divided by 1 minus s squared, all squared. And if you go through the quotient rule, this is exactly what you would get with the quotient rule. Do we have any questions on this one? Once you get really proficient with the chain rule and you use the chain rule over and over and over again, you probably will prefer to do functions like this where it's just 1 over some polynomial. You'll probably prefer to do it this way instead of using the quotient rule. Because with the quotient rule, low d high, the d high when you have just a constant up top is going to give you 0 every time, right? So yeah, as you get more and more proficient with the chain rule, you're going to probably prefer to do these types of problems in this way. But don't ever forget the quotient rule, because sometimes you have to use the quotient rule.
Or would you have to use the quotient rule instead of the chain rule?
If you have, so you either have to remember the quotient rule, or I guess in theory you could forget the quotient rule, but you would need to remember the product rule. So if you have something like f of x divided by g of x, and f of x is not just a constant, well then well, I'll give you a specific example. If we have, say, just 1 minus x squared divided by 1 plus x squared, I want to take the derivative of that. Well, now the trick doesn't really quite work anymore, because the outside function is not really, there's not really clearly any outside function for this function as a whole, right? So you'll have a lot, like every single derivative you take after this class today is going to be, you're definitely going to have to combine rules. You're going to have to use either just the quotient rule here, or you could rewrite this as 1 minus x squared times 1 plus x squared, the minus 1, and then use the product rule, but then you'll need to use the chain rule inside the product rule when you do that. Okay? So, all that to say, like, I'm not, I would probably use the quotient rule on that one, yeah. And there's not, in general, there's no like one right answer for what's the best way to take this derivative. And that's what I like about calculus. You can think of it one way, I can think of it as another, and we'll usually get to the same answer, which is pretty great. And sometimes our answers will look very different because we attack the problem in different ways, but they will really be the same, and that's also very cool. Good. All right, so example, find the equation of the tangent line to the graph of the function f of x equals 2 times sine of x plus cosine of 2 times x at the point pi, comma 1. All right, so find an equation of the tangent line. So my final answer should be a line, right? The equation of a line. So what two things do I need to find the equation of a line?
Slope and 2 points. Well, a point on the.
Yeah, perfect. So I need a slope, and I need a point. All right, We'll do the easy one first. What's going to be the point on the line? Pi comma 1 is the only point I have written up there, right? So the point's going to be pi comma 1. Slope? How am I going to get a slope from this? Yeah, exactly. Anytime you hear the word slope, or you say the word slope at all, you should think derivative. Derivative and slope should now be synonymous in your mind, okay? So the slope, well, I need the derivative, but where? F prime of perfect, F prime of pi. Perfect. All right, so this is really the first time we're going to have two separate rules going on in a derivative problem, okay? So I need to find F prime of pi. First, I'm just going to find F prime of x, okay? So I've got a sum of things, 2 sine of x and cosine of 2x. Do I need anything special to deal with the 2 sine of x? No, I don't need the chain rule at all for that one, right? Oh, we have a question. Oh, someone asked, why is pi the point? So we're finding the tangent line at x equals pi, y equals 1. Okay, so in order to find, so this graph has, it looks, you know, sinusoidal. And so let's say here is pi. I'm finding the tangent line at pi. Well, the slope of this curve, the derivative, the slope of the tangent line at that point is f prime of pi by definition, okay? So that's why we're plugging in pi into the derivative. Okay. So f prime of x, let's find f prime of x first. What's the derivative of 2 times the sine of x? Technically, yes, but also technically no, because we have a special rule for when I think it's great that you heard me say times and you thought product rule. Yes, that's great. But when the other one of the functions is a constant, the constant just comes along for the ride. So you can make it a little easier on yourself. You don't need to use the product rule here when one of the functions is a constant. Okay? Because if we did, let's say we did use the product rule, then the derivative of the first function, well, what's the derivative of 2? 0. And so the first part just goes away anyway. So we'll only be left with the second part, 2 times the derivative of the second function, which is, yeah, cosine of x. Very good. So the derivative of the first part is just 2 times cosine of x. Again, if you want to use the product rule on that, you can. But anytime you do use the product rule on something that's like a constant times a function, you're just doing a little bit extra work that you don't have to do. Okay, and then the derivative of cosine of 2x, what is it?
Is it minus sine?
Careful. What rule do we need here? Yeah, this is a composition, right? I gotcha. So for cosine of 2x, yeah, we don't just take the I don't just give you a number and you just take cosine of x. First, you take 2 times that number, right? So that means because the first thing I do is I take 2 times that number. My inside function is 2x. My outside function is just cosine of x. And so let me move these a little. Give myself some room. So then oh wait, I always do it outside on top because it looks better. Give me a second, everybody. All right, so the derivative with respect to x of cosine of x, you're exactly right, that's negative sine of x. It starts with the letter C, so it has to have a negative, and sine and cosine bounce back and forth between each other when you take derivatives. So there's the derivative of the outside. The derivative of the inside is what? Just 2. Okay, so the chain rule says the derivative of cosine of 2x is, well, where are we going to get? Perfect, negative sine of 2x. So there's derivative of the outside at the inside, derivative of the outside at the inside, at the inside, and then times 2. Because we multiply by 2. Right, the derivative. What was your question? Oh, okay, gotcha. So then the derivative of cosine of 2x is negative 2 sine of 2x. So I'm gonna get minus 2 sine of 2x. Okay. Let me also move this to make it a little, give myself a little bit of room. Okay, so I have f prime of x. Perfect. Now I need f prime of pi. So that's going to be 2 times cosine of pi minus 2 times sine of 2 pi. All right, cosine of pi. Who knows what that is? -1, perfect. So I'm going to get 2 times -1 minus 2 times, who knows what the sine of 2 pi is? 0, perfect. So this gives me -2 for f prime of pi. Okay, so now I have my slope, I have my point, I can write down the equation of this line. So who can tell me, using point slope form, what the equation of this line is going to be? Well, what's the left-hand side going to be? Y minus 1, perfect. Y minus 1 equals, then what? -2 times what? X minus pi. Don't let the symbols scare you. Pi is just a number, just x minus pi, okay? And we're done. I'll tell you, yeah. The -2 is coming from, that's the derivative of f prime, or sorry, that's the derivative of f at pi. Excellent question. Yes, thank you, Sabi, you got it. Any other questions? On the exam, you are going to have to do something like this. I do specify, write the equation in point slope form, okay? So you don't need to worry about, am I in the right form? Am I not? Write it in point slope form like this, okay? Any questions? All right, find f prime of 1 if f of x is sine of pi times x squared. Okay, well, what rule do I need here? Yeah, I need the chain rule, right? So what is my outside function? Outside. What is my inside function? Perfect. Sine of x. What is my inside function? Pi times x squared. Wonderful. And the derivative with respect to x of sine of x is cosine of x. Perfect. And the derivative with respect to x of pi times x squared is 2 pi x. Wonderful. So what's f prime of x then?
Cosine of 2 pi x.
Cosine of, oh, careful. We need outside at the derivative of the inside, or sorry, outside just at the inside. Let me restate that. We need the derivative of the outside at the inside. There we go. Yeah, sorry about that. Derivative of the outside at the inside. Pi x squared. Yeah, there we go. And then we multiply by the derivative of the inside. And so that 2 pi x is outside of the cosine. Okay. And so I'm going to rewrite this like this. You don't have to if you don't want to. I just prefer to have that the 2 pi x out in front. But you don't need to be little mini me's. You can write it however you want. Okay, so then, oops. Then I need to plug in 1, right? I need f prime of 1. So what do I get for f prime of 1? Well, I'm going to get 2 times pi times 1 times cosine of pi times 1. And what's the cosine of pi? -1. So we get -2 pi. Excellent. Excellent, excellent. Any questions on that? All right, I'm going to look at one more. I'm going to look at f of x is equal to, I'm going to write this out as tangent of 2x squared. That's what tan squared 2x means. Okay. Really quick, if I want to find a derivative of this thing, what's the outside function? X squared. And what's the inside function? Tan of 2x. Okay, and so when I take, or when I try to take the derivative of the outside, well, that's easy. What's the derivative of x squared? 2x. When I try and take the derivative of the inside, tan of 2x, what do I need? I need the chain rule again. You need 2 chains here. We got to get 2 chains. That joke sometimes kills and sometimes it doesn't. So, and that's totally fine. Sometimes it's unavoidable that you're going to need to use the chain rule multiple times inside of the chain rule. 2 chains, that's right. 2 chains. And so, in order to take the derivative here, what was that? I thought someone said something. In order to take the derivative here, well, the outside function, if I'm taking the derivative of tangent of 2x, d dx, what's the outside function? Yeah, tangent of x. And what's the inside function?
2x.
Just 2x. And now I can take the derivative of that, right? I can take the derivative of 2x. I don't need to do any more chain rules here. So what's the derivative of tangent of x? Does anyone remember? Secant squared x, actually. That's okay. It's a, why would you remember that? Who would remember that? So d dx there, d dx of 2x is what? 2. So the derivative of tangent of 2x then is 2 times secant squared of 2x, right? I take the derivative here, I plug in this, and I multiply by the derivative of the inside. We'll finish up this example tomorrow, or not tomorrow, on Monday, and then look at more examples like this, and then just general problems where you don't know what rule to use because it's not the chain rule lesson, okay? But this is the chain rule. You all did great. You killed it for real. It seems like you're definitely getting this, and it's the most important rule to understand, okay? So if you have any questions, come talk to me. I have office hours today. My dog will be there. So yeah, if you don't have any questions, please wipe down your desk as you leave, and have a great weekend, guys.